Hello everyone, welcome to the fourth lecture of week 7. We have been discussing various applications, and we talked about question answering, and then we moved on to dialogues. And we talked about open domain dialogues in the last lecture. In this lecture we will talk about another kind of dialogues that were task oriented dialogues. So that will be the topic for today. So we will talk about task oriented dialogues, and we will discuss two different architectures that have been used in the industry for solving this particular problem. And we will give some intuition on how you can use the current methods that we have discussed for solving these problems. So this was an example from the last lecture itself, where we were trying to distinguish the open domain dialogues from task oriented dialogues. So what do you see different here? So here we are typically trying to help the user accomplish a particular task, right? Like here this looks like helping user with train booking. So user 1 and there is a system. The user 1 starts by saying, I need to catch a train from a particular source to a destination, and immediately you get to know what is the intent of the user. You say, okay, the user wants to book a train. So that's very important. Many times you will see systems that can cater to multiple intents. So they can do booking of flights, booking of hotels, setting up alarm clock, and so on. Some system will be specialized for only one particular intent. So if you are only specialized, you may not need to do intent detection, but even there you may have multiple things. Like if you are talking about train reservation, you can book a train, you can talk about cancelling a train, and so on. So that is very important. What is the intent? And then you would have a lot of slots once you go a particular frame. So I want to book a train, so I need to know various slots and values. And this will be already specified in the domain ontology, that okay, if I am booking a train, I need what is the source, what is the destination, what is the date, and so on. So once the user mentions an utterance, you extract whatever information available. So you know, okay, so I already have the source and the destination, but you do not know which day. So you are saying, okay, so whichever slot you do not know, you will ask question from the user, what day will you be traveling? So that's how you will try to get the answer. Now how do you typically do that? You can have some templates that I need this particular slot, so what is the question to ask the value for that slot, or you can use natural language generation by using any encoder, decoder, or decoder kind of models. So user keeps on giving the value, you update the values of whatever slots were unfilled or wherever user wants to update the value, and you accordingly have a sentence reply, right? Again, how do you reply? Can be based on template, it can be based on NLG, where you give everything that the system needs to know what is the reply is going to be, and then you actually formulate a sentence that replies to the query. And then the user may have other questions. How long will the trip take? You actually have the trip time and you can answer. Right? So this is a task oriented dialogue. Now traditionally the frame based dialogue agents have been used for solving this task. So my goal here is to help a user to solve a particular task. That is the idea. It's not about doing chit chat conversation with the user, but solve a particular task like travel reservation, buying a product. And this Genial Understander system, GUS, was proposed in 1977. This was the first proposed architecture for doing it in a very thorough manner and more generalized manner. It can work across domain. It's not about only doing one task, but it can cater to multiple different kind of use cases. So you have to have a structure that represents user intention. So you define what are the intents the user can have while interacting with this particular system, and you will have frames corresponding to that. There will be various frames. So you can have one frame per intention, you can have more frame per intentions, and each frame will have certain slots and values. Like you are saying booking train, so you may have slots like what is the particular source, destination. You may have values pre-filled that these are all the things that can come in my values, right? So that you can do queries like what are the trains that go from this particular source to this destination. You may have some predefined possible values in the slots, right? And you have to extract what value the user is filling by the conversation. So the frame is nothing but a set of slots, and they are filled when the user gives certain information, and each will have a corresponding question. So if you don't have that value, you will ask a question to the user to fill the value. Right? This is also known as a domain ontology. Like here, this is for the origin. So if you want to know the origin, you can ask a question. This can be templated. What city are you leaving from? This is another question that you can ask for origin. Destination, where are you going? Departure date. So it's of the type city, city date, right? So they are of certain type. What day would you like to leave, and so on. So each slot will have a particular question that may be asked to the user, right? But how does this whole control flow happens? That how do you, so what do you want to do at a particular stage of time? So there are two main architectures. We talked about GUS architecture. So this is also known as frame-based architecture. Like this was proposed in 1977 in this AI paper, but it's still very prevalent in the industrial setup, because this is giving very clear idea on how do you build your domain ontology, you build your frames, and how do you understand what the user is asking, the intents, and how do you respond, right? And there's also dialogue state architecture. It's very similar to GUS. It's an extension of that. It's more common in the research system, and a lot of parts are done by machine learning and deep learning based methods in the dialogue state architecture. While GUS is more of a rule based kind of system, where you will have various templates and so on, but here you would like to generate the output rather than having a template. So how does the control structure works for GUS frame? So understand that we have frames and we have slots in the frames. So user system will ask questions of the user, so that it can fill whatever slots from the user response, and it may happen the same response can fill multiple slots, as we saw, right? It can be source, destination, multiple slots can be filled. Like here, I want a flight from San Francisco to Denver, one way, leaving after 5 p.m. on Tuesday. So you have many slots that are getting filled here, like what is the time you want to leave from source, what is your destination, and what kind of flight, one way or round trip. So once your frame is completely filled, what would you do? You have to recover, I mean, what is that flight, right, that matches this query. So that's why you will do a database query. So the idea is that you have a real-time database where you know what are the particular flights that actually satisfy this particular constraint. Otherwise, you will respond with, oh, there are no flights that match your request, right? So then the user will try to relax some of the constraint, and you will again do another database query. So, and they have various condition action rules. So for example, so there are many rules that you have to hard code, like so like for the destination. So once the user has specified the destination, right? So you may have to also do the hotel reservation, right? So there may be different frames, flight reservation, hotel reservation. So once you know the destination slot, it can be the default value that you can fill to the hotel stay, right? Stay location for hotel booking frame. So you are catering to multiple different objectives here: train booking, flight booking, hotel booking. And you can see that the destination city for the flight is same as the stay location, right? Unless the user specifies a new stay location, you would still recommend a hotel for that location. Similarly, once the user has a destination day, that becomes the arrival day, right? And for the hotel stay, this is the arrival day for the hotel reservation. And you can see the need for multiple frames, because you want to cater to multiple scenarios. Even just talking about the flight reservation, you may have scenarios like the user starts asking which airlines fly from Boston to San Francisco. So you may have to have a general route information so that you can respond to queries like that. So one of the main tasks here is that the system must detect which slot of which frame user is filling, right? So detect which frame is being talked about, and for that frame which slots are being filled already, because this is not a good idea to ask the user again whatever values the user has already provided, right? So this will interrupt the flow, and user may not be very much interested in using the system. And whenever you know a new frame has been switched, you have to switch dialog control to that frame. So you may be doing multiple frames in the same dialog, and you have to switch control. So what is the overall thing that in terms of hierarchy? So first of all, for a system you may cater to multiple domains, like you may talk about catering to weather, flight, alarm clock. So typically if you would see all the personal assistants that we have, they will cater to multiple domains. So you may have to detect what is the domain the user is talking about. Is it flight domain, alarm clock? And typically you would want only one of n. So you want one of n domains that you are catering to. If you are only specialized in one domain, this is not needed. You know, you are only working with flights or alarm clock, right? But otherwise, you have to do this one of n domain classification. And once you know the domain, in a domain there will be multiple intents. So like here, maybe find a movie, show flight, remove calendar, application, appointment, and so on. You may have different intents. So you determine based on user utterance what is the intent of the user. So you have domain, you have the intent, and once you know the domain and the intent, then you can go and try to fill the slots. So in an intent, you will have multiple slots. You want to fill the slots, and if the user has not given the value, you ask a query to the user to fill that slot. Right, like here, show me morning flights from Boston to San Francisco on Tuesday. That's the user query. So what you will do, you will find out what is the domain. So domain is air travel, intent is show flights, origin city, origin date is Tuesday, origin time is also given morning, and destination city is San Francisco. So this is the classification you have to do, and that is what will decide what is the next task you are going to do. Right. So if you do not have the slots filled, you will ask a question to get the slot filled. If you have the slot filled, you will do a recommendation. Right. Similarly here, wake me tomorrow at 6. Domain is alarm clock, intent is set alarm, and the only thing is time here, so you get the time. And yeah, you have actually extracted domain, intent, and all the slots. Okay. And then there is dialogue state of belief state architecture, which is just a more sophisticated version of the previous thing that we have said. So it has dialogue acts, that what is the particular action that the user has taken. It's more like doing clarification, follow up, what is the dialogue act. It would have more machine learning, and it typically provides more better generation, because it goes beyond just giving a templated response, but tries to generate using natural language generation methods. And this has been the basis of the modern day research systems typically, and yeah, many of the parts are making way into the industrial systems, like using machine learning for slot understanding and all are widely used. So what are the components in a dialogue state architecture? So you want to first extract the slot fillers from the user sentence using machine learning, that is the natural language understanding part. Then you have the dialogue state tracker, that what is the current state of the dialogue, right? So what are the slot filler constraints from the user already provided, right? So that is what you should have. What is the domain intent? What is the intent? What are the slot and values that you already know? And then one very important thing is the dialogue policy, that what you should do next or say next, right? So like in GeoSystem, the policy was that you keep on asking questions until the frame was full, right? And then you know the frame is full, then you can report back based on your results from the database query. But you can do more sophisticated policy, like when do you want to ask questions? That's a policy. You want to ask question to the user, or you want to ask a clarification question. Suppose you're not clear about a particular slot, you may ask a clarification question. Did you mean this, or sorry, can you elaborate more on what is your, right? What is the particular time that you want to fly? And the analogy would be to produce more natural and less templated utterances. So that's the typical idea, and that's why we are saying it's more sophisticated version of the GUS policy. But the basic ideas remain very much the same. So for example, how would you do slot filling? We can do machine learning. So we have talked about sequence labeling methods, and maybe that can be used for slot filling, right? So we will use ML classifiers to map words to semantic frame fillers. So like this is my input, I want to fly to San Francisco on Monday, please. My output is destination is SF, depart time is Monday. So I want to build a classifier to map input to output, right? Of course, using ML, you need to have a lot of data, right? Where you have the utterances and you know what are the slot and values that they have filled. So once you have that, you can use our sequence labeling paradigm, BIO tagging scheme. So once you have the training data, so what you can do, you have San Francisco, you can put into the BIO scheme. So, beginning of destination and I of destination. Similarly, Monday afternoon, beginning of departure time, I of departure time, everything else is O. Okay. And you learn a classifier that will predict for each word what will be the corresponding tag. Right. So, we will create a B and I tag for each slot type. Yes, and this is my training data, right? And I can train my model on this data, and given a test time, whenever user has an entrance, I can predict different slot values using the trained model. So, like I can use the BERT architecture for doing this sequence labeling. San Francisco is being mapped to B of destination, I of destination, and Monday is the beginning of destination time. And if you want to even classify domain and intent, the same thing can be done. So, you can use either the CLS token that you had for BERT or the end of sequence token, one of these, to build a classifier that will predict what is the domain, what is the intent. Right. So, you can do it jointly, you can do it independently. Right. You can say one of them feeds into another. So, you can have multiple variations of how you want to do that. Right. So, you can actually do all the prediction using a BERT kind of architecture. Yes. So, while we are doing the slot filling, you can also do this domain intent. So, this is the label. airline travel is the domain and search flight is the intent that I am trying to get from this sentence. So, once you have the BIO tagging for the target sentence at the test time, so what you will do, you will extract this filler string. So, you know this is my destination, right, and this is my departure time. Now, it may happen that in your particular ontology, you have only you have specified what are the possible destinations, and you may have SFO, right, in there, not San Francisco. So, you will have to normalize these to find the correct from the ontology. So, like here you will normalize it to SFO, and for that you may have to use some dictionaries, right, homonym dictionaries, like SF, SFO, San Francisco mean the same thing. Okay. So, now given this idea, you have the domain, intent, and the particular slot and values, you would do a dialog state tracking. That is a very important part of the dialog state architecture. So, like here when the user says I am looking for a cheaper restaurant, this is the dialog state, that the user wants information of a restaurant. This is the restaurant intention, and the price is cheap, right. And depending on that, the system will have a policy on what to do next. So, like here the system is asking to fill more slots. So, what kind of restaurant and where, location, and what type of cuisine. So, here so Thai food, so you get food is equal to Thai and somewhere downtown, so area is center, and then you give a particular recommendation, the house serves cheap Thai food, right. And the user asks a further question, where is it the location. So, you have to convert it to, right. So, inform price is equal to cheap, food Thai, area center, and this is the request the user is making for the address. So, this is what you want to do. So, this is the dialog state. So, this is what that is happened. So, you also append the whatever has happened previously, and what is the current thing that you have to do, request for the address, right, for this, and you present the address. The house is at 106 Regent Street, right. So, it looks much more sophisticated than what we were doing earlier. So, that means, so given any particular utterance, I would like Cantonese food near the Mission District, you want to extract a particular dialog state that inform what is the food type and what is the area. So, you have to have the dialog act interpretation. So, this can be like you have a fix n possible dialog acts, you want to classify that, so that you can choose inform, and this can be done based on current encoding. So, you have the current utterance, you can encode that. You can even have the prior dialog acts, you can use that given this prior dialog acts and the current utterance, what should be my dialog act, right. And once you have the dialog act, you can run a slot value after each utterance. So, you can then fill, okay, what are the corresponding slots for this. So, you get the food and the area. So, this is how your flow will take place. Now, rather than doing encoder based model, you can also try decoder based architectures. You can generate things like on this paper they said, okay, you can use prompting with T5 kind of model to dialog state tracking. Like you may have the dialog history as the input to T5 and let it generate, right, all things, right. So, what is the domain, what is the slot and value, right. The domain, slot and value you may generate, and you may have multiple domains like train domain, hotel domain, right. So, this is like given the input you generate everything, that is one possibility, but you can also do schema based prompting, that is okay, you can say you can prompt it with respect to each of the domain and each slot. You can say okay, for train and day what is the value in the same history, train and destination what is the value, another one hotel and reference. So, you will prompt it for everything, right, all possible domains, all possible slots, and get the outputs. So, that is another way of doing that, or you can even have natural language augmented prompt. So, you can say okay, train day, so you can say what the day of the departure, age, right, and it will predict this. Of course, they found this was performing better than the previous this and this, right. So, you can use a decoder kind of model to also do the dialog state tracking. Okay. Now, coming to generation, that how would you generate once you know okay, so I have the information that I need from the user, how do you generate a sentence? That is also interesting, because so you need two stages. First of all, you need to plan what do you really need to say, the content planning, right. So, you need to recommend this hotel or whatever, right? And then once you know what you have to say, how do you say that? So, this is called sentence relation, right. So, content planning is very specific to the architecture that you, so this will be in some domain ontology terms, but then once you know that, then how do you do sentence relation is what we will try to briefly mention. So, that means assume that the content planning has been done by the policy, right. So, it is defined. So, now, so that means you know what is the dialog act that you have to generate, whether you want to ask for clarification or you want to give a recommendation. You have chosen certain attributes, some slot and values that the planner wants to say to the user. Now, either you want to give the answer to the user or just want to confirm from the user, right. So, I am choosing this for this particular slot, this particular value. So, here are some examples, right. So, sentence relation. So, suppose this is your current content planning that you want to recommend, right. So, this is your restaurant name, neighborhood and cuisine. So, this is a sentence you can write. So, Omidi is in Midtown and serves French food. So, this is your natural language generation. Or you can say there is a French restaurant in the Midtown called Omidi. So, there are two different ways of saying the same thing given this particular content planning. So, this part is the content planning and this is your sentence relation. Similarly, here you have this your content planning, recommend particular restaurant name, neighborhood and cuisine, and you have a sentence that does that. So, Lodge Fine is in the city center and serves seafood, right, or there is a seafood restaurant in the city center called Lodge Fine. So, you may like 4 than 3, right. So, how do you do it more natural looking generation is the idea here. Now, the part is that it is very difficult to get such kind of training data in a huge quantity. So, you may not see every restaurant and every possible situation. So, common way to solving it is that you take away the actual names of the restaurant. So, this is called delexicalization. So, rather than saying Omidi, you try to generate based on restaurant name. So, you generate restaurant name is in Midtown is neighborhood and serves cuisine food, right. So, you generate that, and once you have generated that, then you will have an intermediate step where you will replace this fillers with the actual names, right. So, that is typically a more better strategy where you can use even small data, but you delexicalize so that it learns in general, right, and you fill the actual value later on. So, this very important strategy delexicalization, that you replace words in the training set that are denoting the slot values with a generic placeholder token, right, and then you train the model so that it can generate using these placeholders, and we finally replace the placeholders, right. So, yeah, you will say restaurant name is in neighborhood and serves cuisine food. There is a cuisine restaurant in the neighborhood called restaurant name. So, now you can fill in any cuisine, any neighborhood, otherwise you are having to work with a particular restaurant only, right. So, you may not generalize to every possible restaurant. So, and now once you have done this, then you can use the standard encoder decoder architecture. Let us say, so whatever is your content planning will go into your encoder. So, recommend, service, decent, cuisine null, and so your decoder will say okay in delexicalized manner. So restaurant name has decent service. So you can say okay OMIDI, and finally you relexicalize from your database where you already have the value. So you say OMIDI has decent service. So this is what you learn, that given a particular plan with the slots, not the values, this is what I should generate, and then you relexicalize to actually put the values inside this. Okay. Now, how do I typically evaluate this? So there are slightly different measures. So we still use blue, but a delexicalized blue, where so you still use the slot text. So as long as the system has detected the slot text correctly, you are still fine, because other than that, it's just database query, and that's what helps in getting more generalized benchmarks. So like because you may not always have with you the current values and slots. So there are data sets like multi-watch, where you have a lot of different domains, and this is one of the standard data set that people use for dialog state tracking and other such research. So this is one thing. Then inform, that is how often the entities provided by the system are actually correct. That is one measure. Success, whether the system is able to correctly answer all the attributes, and the entity F1. So whatever entity system has returned, what is the F1 score? And for typically for hyperparameter tuning, you use a combined score like blue plus 0.5 of inform plus success. So you want a particular hyperparameter setting that will give you the maximum score. Right. So yeah, I mean this is some description of how a dialog state tracking system will actually works. Chapter 15 of our SLP3 books gives more idea. You may read more from that. So yeah, we will have another lecture this week where we will discuss another application. So we'll focus on summarization there. Thank you.